Arguments can come in several different varieties. One type of argument is called a categorical syllogism. And syllogism is just one type of argument that tends to have two or more premises and one conclusion. Now, categorical syllogisms are named categorical syllogisms because they tend to divide things up into different categories. Now, one example is the following. Premise one, all puppies are dogs. Premise two, all dogs are animals. Conclusion, therefore, all puppies are animals. And now there are a couple important issues that I want to highlight. First, as I said earlier, statements or propositions are either true or false. So, for example, all puppies are dogs, true. All dogs are animals, true. Nickelback is a great rock band. If you ask me, false. And the important point of this is that the truth value of a statement depends on the relationship between whatever the assertion is, whatever is being said, and the actual world. So if I say the sky is blue, yeah, true, possibly, unless it's a gray day. If I say the sun rises from the east, true. If I say the sun rises from the west, false. So a statement is either true or false, and it is such based on the relationship between what you say and how the world actually happens to be. Now, on the other hand, arguments are not true or false. Arguments are either valid or they are invalid. And they're valid if given the premises, the conclusion has to be the case. And it cannot not be the case. It has automatically to be the case. So for example, this argument that you see here is valid. Once you know that all puppies are dogs and that all dogs are animals, it has to be the case that all puppies are animals. And it cannot be otherwise. So in this case, validity depends on the relationship tying the premises and the conclusion. It depends on the entailment from the premises to the conclusion. What is interesting about this is that validity is a formal property of an argument. It's not about what is being said. It's not about puppies and dogs and animals. It's really about the structure of an argument, about how the premises link to the conclusion. Indeed, I could actually change puppies and dogs to something completely meaningless. For example, I could change the argument to all crafts are gibbosity, all gibbosity are nuums, therefore all crafts are nuums. And now these are words I made up. So although I have no idea whatsoever about what any of this means, you know that the conclusion has to be the case. You know, given that all crafts are gibbosity and that all gibbosity are nuums, it has to be that all crafts are nuums. So the argument is valid even if I have no clue what we're talking about. This is what I mean when I say that validity is a formal property of an argument. And see, at its essence, the argument we just discussed looks something like this. All A's are B's, all B's are C's, therefore all A's are C's. And see, let me show this in a visual way, which we refer to as Venn diagrams, which is just a way that is often used to explore and explain categorical syllogisms. So premise one, all A's, so this is the group of all things that are A, puppies, are B's. So all puppies are dogs. So now we've represented premise one. We can also represent premise two. All B's, all dogs are C's, animals. Does it have to follow that all A's are C's? Absolutely. There's no other way. There's no other possible interpretation of all this where the structure of the argument doesn't guarantee that given premise one, all A's are B's, and given premise two, all B's are C's, the outcome just has to be that all A's are C's. It could not be any other way. And this is true, as I said earlier, regardless of whatever A, B, and C are. But if you change the structure of the argument, you can change the entailment. You can change the relationship between premises and conclusions, and this might make a new argument valid or invalid. For example, take the following argument. All A's are B's, some B's are C's, therefore some A's are C's. Is it valid? And if you don't want me to tell you, pause now. Now think about it. In fact, let's draw together the Venn diagram for this argument. So all A's are B's, so all A's are part of B. Some B's are C's, and this is the difficulty. See, some B's are C's could be like this. And if this were the case, it would follow that some A's are C's. The problem is that premise 2 only tells us that there is some kind of overlap between B and C. What it doesn't tell us is if the overlap between B and C also happens to overlap with A, as shown here, or whether it's like this. See, it could be that C and A actually do not overlap in any way. This is still perfectly consistent with premise 1 and premise 2, right? Because premise 1 says A is a subset of B. And then premise 2 says there's overlap between C and B, which is right here. And as I said, this could be the overlap. Right? The overlap could be like this, or it could be like this. And see, given that it's not necessary for the conclusion to follow from the premises, so the conclusion does not logically follow from the premises, given this structure of the argument, then the argument is said to be invalid. And notice, it doesn't mean that it does not follow. It just means that you can't tell. The conclusion could follow from the premises if this were the circumstance, but it's not necessarily the only thing that could happen. It could also be that it's like this, and therefore the conclusion doesn't follow from the premises. Let me give you an example just to make this a little more concrete and maybe more understandable. Let's say that our argument actually goes like this. All A's are B's, so all puppies are dogs, right? All A's are B's. Some B's are C's. All dogs, some dogs are spotted. Does it follow that some puppies are spotted? Well, maybe. It is perfectly possible. Right? It could be that when we say some dogs are spotted, we mean some dogs that are not puppies and some puppies. So in that case, it would look like this. C and A would overlap. But it could perfectly be that it just so happens that none of these puppies are spotted. The only spotted dogs are adult dogs, are non-puppies. So in that case, right, it would look like this, and there would be no overlap between A and C. So again, in this case, you don't know whether the conclusion follows from the premises. It's not necessary for the conclusion to follow from the premises. And again, it doesn't really matter what you put instead of A, B, and C. All that matters is that the logic of this argument does not necessarily require the conclusion to follow from the premises.